The mean value theorem is quite an interesting tool in mathematics. And so here it is. Assume f is a differentiable function on an interval a to b. So differentiable means that the derivative exists at every point in the interval a and b. So then there exists a number between a and b, so that f prime of c is equal to f of b minus f of a divided by b minus a. It does have an interesting meaning. And this goes as follows. So here I draw a graph of a function in black, and then the point A is here, and the point B is here. And then I draw the secant line in blue between the point A f a and B f of b. And now the slope of the secant line is exactly what I've written here on the right. F of b minus f of a divided by b minus a. So it's raised divided by run. So it's the slope of the secant line between the points a f on a and b f of b. And now the theorem says that there is a point c between a and b, so that the function has a derivative equal to the slope of the secant line. We have a geometric meaning of the derivative, which is the slope of the tangent line. Meaning we have a point in between where the slope of the tangent line equals the slope of the secant line. Now this point C doesn't have to be unique, so you can have many more points where the slope is still the same. For example, here on the right, we have the blue line is a secant line between the points A and B, and then we have 2 points, C1 and C2, where the tangent line is parallel. So that's all. That's all the mean value theorem is, but it has some very cute applications, and I will show you one in the next slide. We talked about Usain Bolt's amazing race of 100 meters before. Now Tolo trained really hard on his bike, and he challenged Bolt for a 100-meter race. And indeed, he managed to cycle the 100 meters in exactly the same time of 9.58 seconds. So now I claim that there is a time during the race where their speeds were identical. And of course, this is an example for the mean value theorem. So I would like to use the mean value theorem to find out if there was a time where they had identical speed. So here it goes. So let x beat of t denote the distance run by Usain Bolt, and then xt of t the distance cycled by Tolo. The corresponding velocities are of course the derivatives. So x prime b is the velocity of Usain Bolt at time t, and x prime t is the velocity of Tolo at time t. Now, they start at the same time, which means at time 0, Usain Bolt is at the start line, so let's call that 0, and Tolo is at the start line, which is 0. And then after 9.58 seconds, they're both at the goal. So meaning xb at 9.58 is 100, and xt at 9.58 is 100. I introduce f of t to be x Bolt of t minus x Tolo of t. So then what I have written above translates as follows. So then I have f at 0, this would be x Bolt at 0 minus x Tolo at 0, which is 0. And then I have f at 9.58. This would be Bolt at 100 meters minus Tolo at 100 meters, which is 0. Now, we should note that this function f is differentiable. It is about moving objects, so they cannot just jump around, which means we can use the mean value theorem. So we have a point A, in this case, which is 0. So this would be A, f of A is 0, 0. And then this connects to the point 9.58 and 0. So by the mean value theorem, there exists a point C between 0 and 9.58, where f prime is equal to 0. Okay, let's do that on the next slide. So we do have a continuous function f of t on the interval 0 to 9.58, so that f of 0 is equal to f of 9.58 is equal to 0. So by the mean value theorem, there must be a point c. There can be many points c, but at least one, so that f prime at c is f of 9.58 minus f of 0 divided by 9.58 minus 0, which is 0. So f prime is 0. But this means the following. F prime at c, you remember f was the difference between the locations, so f prime is the difference between the speeds. So x prime of Bolt at time c minus x prime of Tolo at time c. But this was 0, implying that the velocities at time c indeed were the same. And that's what we claimed. So, that's all about the mean value theorem. So just remember this formula. F prime at c for some point between a and b is equal to the slope of the secant line, f of b minus f of a, divided by b minus a. Oh, I think Tolo and Usain are still racing. Let's see how they're doing. Oh, look at this. Tolo, you can beat him. Keep going.